Android reverse engineering. I hope you like this slide. Very funny joke. All of the slides are like this. That's why I gave up halfway, so the back half of this will just be me live hacking. So anyway, first off, who am I? My screen name is Streetlights. My legal name has been censored, but I have an illegal name by which you can call me, which is Jazz. I have pronouns because I'm a real professional. I have socials. This is me. This is the hacker known as Anonymous, my great friend. So yeah, this talk, what's the point of this talk? I'm going to show you how to patch APKs using a bunch of different tools, how to mess with Android software. I'm going to show you how to use those skills to cheat at a little open source game called Shared Pixel Dungeon. We're going to conquer the eyeball zone. All of this is a celebration of user agency. Hack the planet, become ungovernable. So reverse engineering, what do we mean by that? In a broad sense, it's you take a fully completed product, take it apart to see how one would create it. We're going to be looking at two kinds of reverse engineering. Static reverse engineering, which is kind of like reading a book. You just open up the software, you look at the code, you try and comprehend it. Then you got dynamic reverse engineering, where you take the code, you modify it, you see what happens, and that's how you learn what's going on. These two things are complementary. Static engineering, reverse engineering, something you can always rely on. You can always open things up. Dynamic reverse engineering, this is something that an application can try to prevent you from doing. Also, before you know how to dynamically reverse engineer, you're going to need to do a bit of reading to know where to start off. But that's the two things. So I'll be talking about how to reverse engineer Android applications. So why did I pick Android? Well, I think Android is much more accessible than reverse engineering your typical binary. Why is that? Well, if you want to reverse engineer your typical x86 binary, you got a number of problems as a beginner. First off is tooling, what you do when you start reverse engineering. As a complete noob, you borrow a legitimate copy of IDA Pro from a friend. Friend is in scare quotes because reverse engineers don't have friends. So yeah, the problem with binaries is data is code, code is data. This confuses your disassembler. It can try to interpret data as code and it will give you garbage code. It can miscode and then it just shows you here's bits. That's very annoying. Code can be self-modifying, which also prevents you from just statically reading what code is doing. That's a problem. Calling conventions, there's a bunch of different ones. They're all made up nonsense. Someone trying to protect their application or to obfuscate their application can just make up their own. There's no type information in a binary. You go write your own definitions and figure it out for yourself. With regards to tooling, if you don't want to borrow a legitimate copy of IDA Pro, there's Ghidra, which was invented by the NSA specifically to make my life worse. Can never get to work the way I wanted to. There's Discount Bin IDA Pro, which is Hopper. There's the other Discount Bin IDA Pro, which is Binary Ninja. Then there's Radare 2, which no one ever gets to work. So yeah, that's not a problem that you have with Java. We got JDEX, the Java DEX decompiler, world's most okayest software. You will see why. A couple of other things you have. Bytecode is unambiguous. Your disassembler will always be able to perfectly tell you what is this code, what's it gonna do, what is code, what is data, etc., etc. Your code is immutable, so no self-modifying code. The code you see statically in the binary is what is there. All methods, they have names, they have types, they have boundaries. You never have to wonder, is this a random jump? Is this a method? You cannot jump out of a method. Only way to get to a method is to call it with one of these invoke instructions. To be honest, you have too many different ones of them. They're all pretty samey. Yeah. There's also APK tool that just works, except when it doesn't. The tooling in general, it's pretty nice. It's easier to get started with than this whole mess. So that's why I'm teaching you Androids, because it is just more accessible like that. So then, let's hop right into things. We're going to reverse Android applications, or APKs. So let's start by looking what's inside one of those. So, bunch of files here. This is the APK we're going to be reverse engineering. So an APK is just a zip in disguise. If you're running Windows, you might have to rename it to zip before you can open it. Linux knows it's a zip in disguise and it will open it with a zip file thingy. So what's in here? A couple of folders. You got this file, the Android manifest, that one's interesting. This is where your code lives, this is where some resources live. Let's start at the top. Meta-inf, that's some Java shit, you never look at that. Your signatures are in here somewhere, like the ones you use to sign your code. No one ever looks at those. Then assets, these are pretty interesting. Actually, let me demonstrate this with another APK, because shared pixel dungeon is a bit weird. What do I have here? Here, this one's going to be nice. So this is the APK for Tusky, a Mastodon client. See, this one follows the actual Android assets model, whereas shared pixel dungeon doesn't, because it's an old Java game that was ported. Anyway, assets. Tusky only has one, it's a font. So here you can also put some images, that kind of stuff. Most of those still will go into resources. Here you can see there's a couple of folders, different color schemes. You put those in different folders. It figures out which one is the appropriate one. This is all garbage. Let's look at another app. Yeah, I told you I didn't really prepare this. So here, F-Droid. F-Droid is a well-behaved citizen, thank God. So here, your resources, what is this? Animations, you can load those using the Android frameworks, color schemes, drawables, which are like SVGs mostly, although all of these I think are going to be XMLs. Layouts are XMLs that are describe what your app looks like, kind of like HTML does. Menus, maps, etc. Here's some random XMLs. Most of these you will not care about. Sometimes some of them are interesting for a reverse engineer. Especially some of these will have strings in them, which you can use to find entry points in your code that are interesting to look at, etc. So let's have a look at the Android manifest. That's one of the more interesting ones. So I'm just going to open this with JDEX because it's easier. So here you have an Android manifest. What's in there? A couple of things you have. Let's see. This is the supported Android versions, which Android 9, SDK version 9 maps to like Android 2 or something, and 30 is going to map to Android 11. So then here, this is the name of your application, APKs. I told you it was the okayest software. So here, what's interesting is these activities. Those are kind of your entry points into an application. So you can start a random activity from the command line. One of these activities is going to be the main activity, which is going to be your entry point when you start up the application. That one is going to, where is it? Yes, so here you see this intent filter, category launcher that indicates that this is the main activity, the one that starts up when you open the app. So that's interesting. So Shattered Pixel Dungeon, as I already told you, it's a Java app, so it was ported to Android, so it's not very very standard with the way it does things. It doesn't really doesn't make much use of the Android ecosystem. So that's why I wanted to show you Tusky, because it has interesting things in its manifest. So, no, not that one. Here, what can you see in the manifest? These are all the permissions that your app is going to ask for when you open it up. Then you got a bunch of different activities. If like apps use things like Google location services, Firebase that will be in here somewhere. You can find a bunch of junk libraries in here. Those usually you don't care about them. It might be interesting to figure out what kind of libraries an app is using, I guess. So then, the important part is these activities. Here, the launcher. Then another thing that can be interesting is here in this application line. When you're modifying this manifest, here you can add a property Android debuggable equals true. You need to add that if you want to attach a debugger to your app. Libraries. I just told you that native libraries are horrible. Unfortunately, there's a bunch of these in Android apps as well. So usually, most of the interesting code will be in Java. So yeah, these are just ELF files. You can reverse engineer them with IdaPro, Ghidra, etc. I will not be showing you how to do that. I can show you how you can tell what functions are actually defined in there though, because everything that you're calling into from Java will be using JNI, the Java native interface. So what you can do if you want to know, this one doesn't have libraries. If you want to know what kind of functions are inside a native library, just unzip it, come on. Then you get your terminal, you do read elf sims on your native library, then you grep for Java. Let me just. These are all the functions you can call from Java. You can see they have their signatures mangled. So this is from the combat. You can pass them as arguments into functions. It's all relatively high level. So then, what else did I need to tell you? It's aesthetically just as pleasing. You put it through the Java compiler, which gives you a class file. Then you put that through the jar tool, which will put multiple class files together. You also put like your manifest and some resources into the jar, etc. With Android, you start off the same way, Java code into a class file. Then you use the D8 tool to turn it into a Smalley. Well, Smalley is the disassembler. It's a DEX file actually, but Biggie Smalls was an easier joke than working with DEX. Anyway, he put it through the R8 tool, which makes it very small, compacts it. Then it goes into an APK together with your manifest, your libraries, etc. So then the difference between these two, Java is a stack machine, Smalley is a register machine. For everything else though, they're pretty much the same. Okay, those are our slides, let's get hacking. So, the game we're going to hack, Shattered Pixel Dungeon. I forgot to install it. So, first off you can ADB install. You got the ADB tool that comes with Android Studio. You can use it to have a shell on your emulator or device. Very convenient. So then, Shattered Pixel Dungeon, a little game where you conquer the eyeball zone. So when you start off, you can use one of your classes. This is the Adam Driver class, he punches things. The other ones, come on. You've got the Unix user, which we haven't unlocked yet. You got the Nasty Crime Boy, you also got to unlock him. Then you have the woman, also got to unlock her. So we don't want to do those unlock quests. So we're going to do a bit of hacking. So what we're going to do is, I'm going to read this message here. So this is the unlock message. The rogue can control blah, blah, blah. So how are we going to figure out where in the code to fuck with things to unlock this asshole? Well, we start by unzipping our resources, which I think I've already done. Yeah. So we go to resources here. We're just going to grab for this string we have here. So the rogue can control. Rogue can control. Huh. Am I looking?
Capital R.
Huh?
The rogue with capital R.
Did I not set it to insensitive? Wait, let me just. Yeah, I apparently forgot how grep works, but I also haven't opened in. Let's just use cheats and use find in files in Android Studio. So here you got the rogue can control flow of battle. So here you can see the string, it uses some localization mechanism, so the string isn't present in the code, but it has an ID, and probably the ID is going to be present in the code. So if we go for TID, that's rogue unlock. We don't want to be looking there. We want to look in the code only. So yeah, I already dumped the Smalley code here. We can see that the string is used in the hero class. So let's open this up in JDAX. What's the full class name? Is what all the way up. Shared pixel dungeon, actors hero class. Right. I have it open already here somewhere. I think probably. I need to learn how to organize my shit and get my life together. So rogue unlock. So here you got this unlock message function. Let's see from where there's called. No, not define usage. It's called in one location, very convenient. Before it does this, it checks an is unlocked function. That's very interesting, so let's look at that. So here, probably if we override this function to just return true, we can just use the rogue, so let's do that. So how do you do that? Let me clean up some shit here first. Already did this 5 times. So first you use a convenient little tool called APK tool to completely disassemble your application. This takes a second. Then you can look in the Smalley is where the code is. Then it's going to be the entire package name. So com shared pixel dungeon, actors, hero class. Then, yeah, it immediately goes to the right function because I've done this before. So here you can see this is our function. It's in assembly. So how do we have it return true? Well, we have it return true here, so we can just copy paste that if we can figure out what it corresponds to. So that's going to be your first return here. Then v1, what does it write to? Just writes a 1 to there, because booleans and integers are the same, I guess. So then we've added assembly code for return true way up top. Then we reassemble this thing. This is going to take another second. So then we should have a freshly patched APK ready to go. So it puts these in dist folder. Then before you can install an APK, you need to do a bit of housekeeping. So I don't know why APK tool doesn't do this itself. But first you need to align this with zipline. For I don't know why you need to do this, it's just random nonsense. It scares away to noobs, I guess.
Google logic.
Yeah. Google's ecosystem, it's very fun to work with. All their toolings just amazing. It all makes perfect sense always. So we create a zip aligned APK, and we gotta sign it with our debug keys. So APK signer, it's a Google tool, which is why it takes all this ridiculous amount of arguments. Just Google how to do it, I guess. So then we signed this with a different key than the original one, so we have to uninstall the original one first, or it's going to complain about that. On my work laptop, I just have scripts to do this, but this is my personal laptop. So then we can install our freshly patched APK. And then
is this a virtual Android on the right, or is it a remote control for your actual phone?
no, this is an emulator
Yeah.
because, yeah, it just comes with Android Studio. That's the only nice thing about the entire Google ecosystem is you install Android Studio, it comes with every single tool you could possibly need. So anyway, here we patched out this check, and now we can play as Adam Driver, Unix user, crime boy, or woman. So that's pretty boring. Let's do something more interesting. So it is static reverse engineering. You read a bunch of code, you added some code. We're going to do something more interesting now. I'm going to use a tool called Frida to dynamically alter the behavior of functions, modify data on the fly. So Frida, again, it comes with a bit of messing around first. So before you can use it, you need to ADB push this binary to your device. Then you need to make it executable. Then you need to actually execute it. Come on. Then we can normally start up Frida -u-f com why is it complaining? Okay, that's no big deal. We'll just have to figure out the PID. It doesn't like that Shadow Pixel Dungeon has like a weird name, like the launcher name does not correspond to the package name. But what we can do is we can just grab for the PID and connect to that. So now we have our magical hooking tool attached. And that will allow us to just manipulate this application on the fly. So you got your little boy here. He only has a measly 20 hit points. Maybe we'll want him to be a little bit tougher. So we can just go into Frida. Then you need to know what the class is of the little boy over here. For this, I like to use a little trick, which is called having read all the goddamn code in advance. So then you can use this Java use statement to just like grab a class. What is your problem? Why does it not like this? I knew when I was going to do a demo that everything would suddenly go wrong. Let me just reinstall the fresh APK, maybe that will help. This is what you get for cheating at games. So yeah, maybe now we'll want to know. Huh. So let's so now we should be attached. Huh. Why are you doing that? Come on. Can I at least trace this thing? No?
No, but the PID isn't in it.
Right, that was not a PID, that was...
The port of your Android emulator.
Yes. Right. See, that's very funky, because the tracer obviously does find all the classes. What did I do wrong? Whoops. Oh yeah, if you attach the tracer, it works fine. If you kill the tracer, everything goes to shit. Yeah, Frida is very fun, but it also has some issues sometimes. So Frida PS. Apparently we're not allowed to hack today. That's embarrassing. Does it find any other classes? Let's see. Nope, that's not the right terminal. Huh. Yeah. Does any of you know how to reverse engineer an Android application? I could really use some help right now. Damn. If I load a script, will that work? There we go. Absolute magic, now it just works. Anyway, that cost me like 10 minutes. Anyway, now we have Frida up and running. Now we can just fuck around with whatever. So what I did, I just grabbed the dungeon class, which has a static field, which will point us towards the hero class, which then points us towards the hit points, which we can then just give any random value. Here, now we're adding driver boy, infinite healths.
Is that actually what I saw that it like auto completes what you're typing in? Is that Frida actually auto completing what you're typing in?
Does it have auto-complete? Yeah, it has auto-complete. It's not auto-complete, it's like look ahead, yeah.
Yeah, that's
Oh, we
cool.
can actually go through it also. Yeah. So then, I already also attached some scripts, so you can script Frida. Where do I have them open? I attached this script. So here, what we're doing is we're overriding functions on the fly. So what I did is, here I found function that calculates how much damage you're doing, override it just to return 999. There's a function to check if your hero is alive, override to always return true. It doesn't, sometimes gets into an inconsistent state with that one. It doesn't really like that one, but works just good enough. So then we got those two functions loaded right now. And if we find an enemy somewhere, you'll see. So yeah. So yeah. Then I was also going to, what I wanted to show was like to figure out a function that uses to skip to a certain level, except if you run that one from the command line, it just crashes because it needs a whole bunch of states set up first. And Frida's not good at that. So yeah, anyway. I wanted to show you how you can use trace to like also figure out what functions are being called. So you can figure out how to find those functions you want to override. But instead I spent like 10 minutes fucking around.
Next speaker is in 20 minutes, so if you want like a little bit more time to show stuff.
Sure, I can do that. So then, oh yeah, it was another thing that I wanted to show off. So, shared pixel dungeon. When you find a new item, you don't know what level it is or where it's cursed or whatever, typical roguelike. So I can show you a little hack that, why the fuck did Frida just die? Oh wait. Yeah, the server timed out, it does that sometimes. Great software. So yeah. So what I want to do is write a little bit of code that will log all like the levels and curses that an item might have, so we can see whether it's good or bad. So how do we figure out what code to override for that? Well, you have this tool called Frida trace. Here we're going to go in a very annoying back and forth again, because every time you close Frida trace, your app will crash. I don't know why. Great software. So let me first check what PID we have. 6925. So you can use Frida trace on your PID. We'll just show you every single function that's being executed. at least if you put it in your whitelist. So let's just start with looking at all user-defined functions. So all packages is a wildcard, is the package method separator. All methods, then U for user-defined. Ah, right, the server died. Is it going to let me reconnect like that? Okay, so yeah. Sometimes you need to just turn it off and on again for it to work. So this is our PID, copy that. Working. So yeah, you can see here, Shattered Pixel Dungeon is a great game that runs at 60 FPS. So what you're seeing here is the rendering loop. So I've already stared at this shit a bunch, getting very frustrated with it spewing out all that stuff. So I've already figured out most of the functions we don't care about. You can exclude those with capital dash J. So like we're only including things in the Shattered Pixel package. We don't care about things that are called update or draw, align, process, shield, now, render, etc. Also TSLI function, which it apparently calls at every rendering loop. Don't ask me why. So if we attach this, that's the wrong PID. Normally you can just attach to a process name, but Shattered Pixel Dungeon has spaces in its name, which it doesn't like. So yeah, 7, 6, 2, 9. So yeah, also fun thing about trace is that we'll like dump a bunch of JavaScript in whatever directory you're in. So here, yeah, I apparently didn't get all of the functions that run every second. So here I'm just going to click on an item to see what functions are executed, and then close this very fast before it's spammed away. So here you can see everything that's being executed. This is some rendering code. This is localization, rendering. Let's look for something that looks interesting. These are all just messages. So here you can see it render the description. So here we have, it's calling out to item.level, item.buffLevel. That's probably what we want to look at, right? So let's open JDX, look for those functions. So here, let's look at a class, search for a class called item. Then let's look for a function called level. Maybe level isn't the greatest. What else do we have? Where did I put my terminal? Here. You got this function called description, where you can guess that's probably only going to be called when you look at this one. So we got this desk function. We know that's going to be called on your item whenever you look at it. So then we're going to override it. We've already found some interesting functions like level, and then if you look at the actual class in the overview here, where is it? Items. Item. So you can see all the functions that it has here. Level is going to be interesting. True name is going to be interesting. There's a regular name. So then, I've already done this, so I already wrote the script. So we were just going to grab the item class, override the description function to log the name, the level, and the true name for every item we see. So then, instead of invincible, what we want to perform is spoil description. Then just gonna close this terminal. Frida Geo. Load our scripts. And now you can see that if we click on this, it's going to log the real name and the level. So that's another cool hack you can do, I guess. So, yeah. That's about all the things I want to demo. Let's go back to the slide deck. I only had like 20 slides and I skipped like half of them. Yeah, so the tools you want if you want to reproduce this, you got SDKman, which you use to install the Java and Kotlin toolchains. That's interesting if you want to just compile a piece of Java code. Then you can use the Android tools to convert it to DEX code. Then you can like inject that into an application if you don't want to write the assembly yourself. You got your disassembler and reassembler, that's APK tool. Your decompiler, that's JDEX. Your hooking tool, that's Frida. Then some resources. Top one is a very good static reverse engineering tutorial by Maddie Stone, which I very much recommend. It's what we show all the new engineers at my company. Then for Frida, 2 repositories that have a bunch of code snippets. Frida uses JavaScript and is a very annoying API, so you don't ever want to write any of it yourself, you just want to copy paste it from the internet. If you want to go over these slides, you're up here. So anyway, yeah, that's the end of my 50-something minutes of embarrassment.